All right, guys, so we are back and we're going to continue with this question. So Mr. Lamar, so you want to continue walk us through how to find the height of the tower based on this diagram?
Yes, sir.
All right, so tell me what to do then.
So now you're going to find the vertical height, so a part from point B to point C,
All right,
which is
so,
X.
so based on the right angle triangle,
Yes, sir.
we want to find the height from the base of the right angle triangle. So from the base of it, and let me draw a line. So we want from this base, so you want to find the height to the top of the triangle. So you're saying we need to find this height.
Yes, sir.
Okay then.
And you're going to add up to 1.5 meters.
All right, so what can we do to find that height?
All right, so the formula for tangent in there, sir, would be, so that would be X. Then you'd have BC.
All right, so we're working with H. So H is the height, but we know
so off H.
This little part up here, this blue section here, would be just X.
Yes, sir.
All right, what else?
So X equals.
All right, why don't you write the trigonometric ratio before you?
All right, sir. Tan equal.
All right, so we're using tan. So we are saying that tan tan of what? Tan of 30 degrees equal to, continue, Mr. Lamar. Mr. Lamar, are you there?
Yes, sir. Yes, sir. Might in mute.
Okay.
BC over AB.
Okay. I have an IT department. Could this person identify themselves? Who is in IT department? I'm going to remove this person from the list. If the person won't identify themselves, I'm going to remove them.
Okay, sir.
Yes, okay, all right.
So BC over AB.
So we have BC BC over
AB.
All right, so AB here you could just go ahead and put in the values for these. So we know that the tan of 30 degrees would be equal to
X over 100.
over 100.
So don't forget X by itself
All right, so X by itself.
would be equal to X
Alright.
equal.
All right, so we can say, all right,
X.
let us keep the X on the right-hand side. So transposing, we're going to have
Yes, sir. 100 over tan 30 degrees.
All right, I want to take it in steps so that we don't lose anyone. So we are taking the 100 that is in the denominator on the right-hand side. We're moving it across to the left-hand side and multiplying the tan 30. Because remember, if it is dividing on the right, you move it to the left.
Left is going to be multiplying.
Right. All right.
Yes, sir.
So we will have 100 tan 30. And that will be equal to X.
Yes, sir.
All right, so we can go ahead now and do the calculation of tan 30. So we know we can flip around the equation, put in the X now on the left, and do the calculation of 100 tan 30 on the right. So we
Yes,
will have
sir.
100 times the tan of 30.
Which is point. This is 0 point.
So 100 times 0
.577.
577. So X would be equal to
57.7.
7.7. And in this case, we use whatever unit the question.
So 57.7.
Oh, it's 57.7. All right, sorry. And that would be in terms of meters.
Yes, sir. Plus,
So what next?
sir, H equal X plus
Is equal to X plus.
the height of the theodolite from the ground.
All right, so let us call that.
Why?
No, let us just give the height. Put in the height. So it's X plus 1.5. 1.5.
Which is then equal to
So H now is equal to
59.2 meters.
let us put in the X, so it would be 57.
0.7.
plus 1.5. So H is equal to
59.2 meters.
how much?
59.2.
59.2 meters. All right. All right. Anybody agree with Mr. Lamar's calculation? Does it make sense to you guys? Anybody? All right. So that's two persons so far, Miss Waysome and Miss Green. All right, and Mr. RJ. All right. Thanks much, Mr. Lamar. Ms. Caveira, I saw you just came in. Are you following what is happening here?
Yes, sir.
Okay. All right. So is it clear for you what the calculation should be? We're calculating the height of the tower. All right. So let us move on to another example. So let me clear what I have here. All right, so this would have been the calculation from what we just did, guys. So from the right angle triangle, we would have calculated the height of BC, which is the height of the leg of the triangle. And so that would be 100 times 0.577, which gives us 57.7. And now the height of the tower, which would be BC plus 1.5, would be 57.7 plus 1.5 meters, which gives us 59.2 meters. All right, good. All right, looking now on this example, before we actually work this example together, I'm just going to ask you to try on your own, construct the diagram, and do the calculation. I'm going to give you about 3 to 5 minutes to do this. And then now I'll ask someone to walk me through the question. Now, preferably somebody other than Mr. Lamar. All right, guys? So I'm giving you 5 minutes to construct a diagram, do the calculation for what is being asked, and then now be prepared to walk me through the solution. Guys, I was just saying just now, I will give you an opportunity to do your construction of a diagram to this question. And then now, were you hearing me just now when I was walking you through the question before? When I was going through this part, guys, were you hearing me? Because I realized my mic was on mute.
Yes, sir.
Were you hearing me when I was walking through this just now?
Yes, sir.
Okay. All right. So as I was saying now, with this question, I'm just going to allow you to construct the diagram, do the calculation for what it is asking you for, and then I'm giving you 5 minutes, and then I'm going to ask someone to walk me through the question. So preferably somebody other than Mr. Lamar. All right. All right, anybody is ready? Is there anybody ready to walk me through this question? What about you, Ms. Waysam? Are you ready?
No, sir.
All right. Anybody else? Apart from Ms. Waysam? Ms. Green?
No, sir.
All right, I'll give you a little bit more time to figure out. All right, guys, whenever you're ready, just raise your hand so that I'll see who is ready to walk me through.
Sir, we have an idea, but my calculator now work to make work out the math itself. Seems like the calculator battery is dying.
All right, guys, so do you want me to walk through this question with you then? Raise your hand if you want us to do it together. Okay then. All right, we'll do that. All right, so the first thing you'd have to do here, guys, is to construct your diagram. It says a flagpole is 50 meters high. What length of shadow will it cast when the altitude of the sun is 57 degrees? Now, if we're talking about altitude and the degrees of 57, we know clearly that would have given you your what? What angle will that represent? Will that be angle of elevation or angle of depression, guys? It's not a trick question, somebody can answer. If you're looking up, guys, what angle would that form with the line of sight? Horizontal.
So that would be angle of elevation.
Exactly. So, all right, so we know that the shadow is cast on the ground.
Sir.
Is that Miss Wilson? Your voice is a little bit slurred. So I think the network is somewhat slow. All right, so let's say that the shadow is on the ground, guys, and the sun would be shining up from above so that you have an angle of elevation of 57. All right. Now, it doesn't matter if you put your angle to the right of the pole or to the left of the pole, whichever way you want to draw it, will be okay. Ms. Cabrera, are you saying something?
Sir, that was the problem I had, like where to put the angle.
Okay, all right. So because we don't really have, in this case, a person standing up and looking, we're just saying that the shadow would be on the horizontal of the ground. All right. Because when a shadow cast, it is cast on the ground. So we would take the horizontal to be the ground level. All right. All right, so once you have constructed this diagram, then clearly what they want you to find is the length of the shadow from the pole. So we would label that X. And so now we would have to do our calculation. And so from here, you should be able to do some calculation, guys. So do the calculation and somebody present me with the length of X, please. So I'll give you about 3 minutes to do that. Anyone ready to walk me through the solution now? Do I have to call on someone? You want to walk us through it now, Ms. Cabrera?
Okay, but I haven't finished calculating.
All right.
It will be tan angle equals.
All right, so let me, right, so we are using tan of 57. And that is equal to?
15 over X.
All right, 15 over X. All right, so what do we do from here now?
Make the 15 the subject.
All right, so what do we move now?
Move the 15 to the left. So it'll be 15 tan 57 equals X.
You sure that is what you want to do? Because remember, our aim is really to get the X to be the subject. But remember now, once the x is in the denominator, we need to get the x on the other side and do the opposite of what the x is doing on the side that where it is now. So what is the
Yes, sir.
x doing with the 15?
It's
On the right,
multiplying.
on the right hand side, what x is doing with to the 15?
Sir, it's multiplying.
So remember now we have 15 in the numerator and x in the denominator. Remember, you can treat a fraction as a the bar in the fraction, you can treat it as a division bar. So it means that what is below divide what is above. All right, so the x is dividing the 15. So if it is dividing it on the right hand side, what we're going to do now with the x?
Put it on the left hand side.
And then what are we going to do when we are on the left hand side? What operation?
Do you say multiply?
Exactly. So you're dividing on one side, you go to the other side, you multiply. All right, good. So we have x now times tan of 57. And that would be equal to 15. All right, but does that make x the subject? When we move the x to the left, is x the subject?
Yes, sir.
Not yet. X is the subject when it is by itself on one side of the equation. But remember now, to the left, we have x times tan 57. So we need to get rid of that tan 57 from beside the x. The x is multiplying with the tan 57. So what are we going to do with tan 57?
Find tan 57.
Not yet. Do the transposing first. Move the tan 57 to the other side. What are we going to get?
Tan 57.
So x on this side, move the tan 57 to the other side. We're going to have what?
Equals tan.
If,
Equal.
if the tan is multiplying on the left, when you move it to the right, what you're going to use it to do? Remember, you have to do the opposite. So if the tan is multiplying the x on the left, you bring the tan on the right and divide the 15. Following, Miss Cabrera?
Yes, sir.
Okay. All right, so now you can use a calculator to find out what tan of 57 is. And then now we can do that calculation. So x is equal to 15 divided by what? What is tan 57?
Sir, I got 1.54.
All right, good. 1.54. One other thing I must bring to your attention, students, for the sine and the cosine ratios, you will never get a value which is greater than 1. That is for the sine and cosine. But for the tan, you can get a value greater than 1, or a value which is 1 or more. Is that clear, guys? So that's something to bear in mind. When we divide 15 now by 1.54, what do we get, Ms. Cabrera?
9.7.
9.7. And in terms of this would be centimeters, as they're using the same units in the question. And this would represent what? This 9.7 would represent what?
X.
What is x again, based on the question?
The adjacent angle.
No, man, look
Oh,
at
wait.
it. Huh? Go again, Miss Cabrera.
So it would be the length cast when the altitude of the sun is 57.
All right, so it's the length of a shadow. All right. All right, so thanks much for that. Is everybody okay with this question? Raise your hand. Following so far, guys? Make sure you're paying attention. All right, so I'm going to clear what we have here. Move on. All right, the Zoom may run out shortly, so you know what to do. All right, so walking through the question once more, guys. So we're looking at the angle. We could take the angle C2 as well. All right, so if we are working with angle C, we would subtract 57 degrees from 90 because we know that angle C plus angle A would give you 90. So we know angle A is 57. We subtract that from 90, we get 33. So we could work with that angle for at C2 as well. So up here would be 33 degrees. And if we're using this angle, we're just using whatever angle to calculate X. So now if we're working with this angle, the opposite side would be AB, which is X over BC. So the tan of 33 is AB over BC. And so we would get